Ever wondered why your first EMI is mostly interest? Let's build a Python Flask calculator that exposes the truth behind every loan payment and escape the debt maze together. Hey everyone, my name is Vivek and welcome back to Escape Room Coding. Today we are taking on one of finance's trickiest puzzle, loan amortization. By the end, you will have a working app that reveals your payment breakdown, total interest, and remaining balance. Skills you can use for job interviews, side project, or your own finances. Here is how we'll escape one room at a time. Room 1, the math maze, amortization logic. Room 2, Flask Foundation. Room 3, Frontend Escape. Room 4, testing and debugging. We'll test real-world scenarios. If you want to break out of tutorial hell with real projects, hit subscribe and let's get started. Let's deep dive into the world of loans together. I will break down the loan amortization formula in the easiest way possible, guide you through a step-by-step example, and then reveal a full 12-month schedule. By the end, you will have a crystal clear understanding of how loan really works. The monthly payment formula is M equals to, where M is the monthly payment, P is the principal or the loan amount, here R is the monthly rate of interest or annual rate divided by 12, and N is the total number of months. This formula makes sure you pay back both interest and principal in equal monthly installment. For example, let's assume that you took a loan of rupees 1 lakh and your annual rate of interest is 12%. So the monthly rate of interest would be somewhere around 0.01 and term or the total number of months is 12. Let's plug these values into the formula and we will get somewhere around 8,884.17. So your EMI is about 8,884 per month. For the first month, your interest rate would be P into R, which is the principal amount into rate of interest, and this will give you 1,000 rupees. So if you subtract 1,000, that is the interest of month 1, with the monthly EMI, that is 8,884 rupees, you will get 7,884.17, and your remaining balance would be 1 lakh rupees minus 7,884.17, which is equals to 92,115.83. Notice that in the beginning, more of your payment goes to interest and less to principal. Let's extend this concept to 12 months. Month 1, EMI is 8,884.17. Your interest is 1,000 rupees and you paid a principal amount of 7,884.17 and remaining balance is 92,115.83 rupees. If you see the second month value, the EMI remains the same, but the interest reduces and the principal increases. If you see the third month, the interest reduces further and it becomes 841.53 and your principal amount increases too. By the end, almost your entire payment goes towards principal. That's how amortization works. Equal payments every month, but shifting portions of interest and principal. In the beginning, the bank earns more interest and over time, you gain by paying down more principal. Now you can read your amortization table with confidence. Hey, congratulations! You have just escaped room 1. Seriously impressive. Now, welcome to room 2, Flask Foundation. Get ready to level up as we dive into the basics of Flask and start building our coding escape toolkit. Let's build this app together. Alright, so this is my project setup. For this project, we'll be using Flask and matplotlib for the graph creation. Let's create a virtual environment, activate it, and then install the libraries. We can create a virtual environment by using this command, python -m venv, and then give your virtual environment name here. I'm just giving vtest, press enter. So our virtual environment got created. Let's activate it. Just type the name of your virtual environment, that is vtest, and then inside this folder, there is another folder called script. Write that as well, and then write activate. Hit enter. Once you see the name of your virtual environment over here, like vtest, that means the virtual environment is active. Now we can install the required libraries. To install those libraries, we can use pip command, pip install -r. Now just give the file name, that is requirement.txt. Hit enter. Alright, the libraries are installed. Now we'll create our tables. Okay, so this is our first table, loans. Here I have an ID column, which is going to be our primary key of this table, and it is auto increment. We have amount, annual rate, terms year, start date, monthly payment, and created date. So all these columns are very important for the calculation of monthly EMI payments. Next, we are going to create payments table. Alright, so here is the code for creating the payments table. Again, we have an ID column, which is going to be the primary key field of this table. We have a loan underscore ID column, which is going to refer to ID column of loans table. And this will act as a foreign key, as you can see over here. We also have a column for payments number, or how many number of payments we did, payments date, what amount we paid or what value we paid, interest, principal, and balance. Now it is time to create our routes in app.py file. First, I'm going to import all the required libraries for this particular application. Let's create a variable called db, and this will represent our database loans.db. Alright, now let's configure the Flask app. So app equal to Flask name, and this is going to be our secret key. If you are going live with this project or any project, don't use a simple secret key, make it more complex. Now let's create a helper function to get the database connection. def get underscore db. Here I am creating a connection object, and connection.row factory equal to sqlite3.row and returning the connection. What this line does is, let's say for example, you select some values from a table called user, and you can access the row using the index, for example row 1 or row 2, like this, right? When you use this particular line where connection.row factory equal to sqlite3.row, this will allow us to access those rows and values using the column name, like this. Now that we have our database connection, let's initialize our database. Right, so I'm getting the database connection and opening our SQL schema or schema.sql, which is this file, opening it into a read mode as f. Here f is going to refer to each line, or it will read each line inside this file in read mode, and then we are executing the entire SQL script, this script, which is going to create our table. Once it is done, we are committing the changes and closing the connection. Now we just have to call init underscore db function. This will do the trick. This function is going to be the main engine for calculating the payments or amortization. Here we are converting year or number of years into number of months. If number of months is 0, we are just throwing an error. Term must be greater than 0. Else the rate of interest would be annual rate divided by 100 and divided by 12. Now this line is very important. It basically means if the interest rate is 0 or extremely close to 0, let's say tiny floating point number, treat it as 0. Now this is the formula we already checked in room 1. It is going to calculate the EMI or the payment for each month, and we are just returning the payments. Now we are going to write a function which is going to generate the schedule for the entire term. Right, so here is the function which is going to generate our schedule. So this function return list of payments like dictionary with payment numbers, date, payment amount, interest, principal, and balance. Now this loop is very important. Inside this loop, we are doing multiple things. First, we are calculating the interest. Interest is going to be balance multiplied by rate of interest. If rate of interest is greater than 0, else it will be, the interest would be 0.0. We are also calculating the principal part. So principal is going to be payment minus interest right over here. So this is the logic where we are handling the last payment or the final payment. The principal can be greater than balance. In that case, we are just assigning principal equals to balance, and payment amount will be equal to interest plus principal. The principal can also be less than balance or equal to balance. In that case, we are just storing the payment into payment underscore amount variable. Okay, this payment is going to be the monthly EMI. So here we are updating the remaining balance. Let's say balance minus principal, and then we are converting or rounding up the value, avoiding floating noises, and saving all these calculated values inside the schedule list. So we are storing number of payment or the payment number, payment date, payment amount, rounding up the payment amount to 2 decimal places, interest rate, again rounding it up to 2 decimal places, principal amount, and the balance. and finally returning payment and schedules. Now let's create a DB helper function, which is going to help us save the record in our loans table and in payments table. Right, so this is our function. Now let's create a function to read data from loan table and payments table. Alright, so I've created this function fetch_schedule that is going to accept a loan ID, getting data from loan table where ID equals to the loan ID, running a select statement for the payment table. We are just returning loan and payments list. Alright, now the very important thing, that is creating a function to plot graphs. So here is the function to do that. This function is accepting all the schedule. We are just extracting the values from the schedule list. Here we are just creating the graph. Creating an object of bytes IO, and this line is going to convert this graph into an image of PNG type, and at this line we are just coding that image object into a stream of characters right here. Now let's create our first route. So this is pretty simple. This is our root route. When we visit our application, we are just going to return the index.html template. Now let's create a route to calculate those values or to call those functions which we just created. Alright, so this is the route calculate, and it is going to accept post method. While generating schedule, our generate schedule function can throw some error or exceptions. To handle those, we are using try except block. Once we have everything, like, we are just calling this save loan and schedule function to save these values into our database table. Then calling the function plot_schedule is going to create a graph, convert that graph into .png and return the streams of, or the character streams of that image into img_b64. And then return these things. We are showing these values in our result.index file. I hope you guys have understood till here. Now let's create a function to get the loan values or the loan records and payment records from our tables. So this is our loan_view function. If we have the payments from here, this function converting that schedule into a dictionary so that we can access the values like this. And then we are just getting the graph image from plot_schedule function. And then returning everything into result.html file. Alright, we are almost done with our backend or app.py file. We just have few lines of code to write. Here it is. So this is just going to run the application. If name equals to main, then execute this app. Great progress. Now welcome to room 3, Frontend Escape. Here is where things get interactive. We'll build dynamic forms, collect user input, and make your apps come alive with real-time feedback. First, we are going to build our base.html. Now remember, I'm going to use Jinja 2 templating, and base.html is going to be our foundation for all the HTML pages like index.html and results.html. We will extend base.html into indexed and results.html. This will make sure that our application's design is consistent for each HTML pages. So here is our base.html file. I have just added a title and I've created a link to our CSS file, which is this file. We have not created anything inside style.css yet. We'll do it in some time. Looping through all the messages and displaying each message, whether it is a success or a failure or some validation error, we are going to show everything in this section. This is where our content for other HTML file is going to show up. Save it. This is our index.html file. We are extending it from base.html, and the content of index.html file is over here. We have a title called enter loan details, and I have created a form to accept loan details like loan amount, rate of interest or terms, start date, and a submit button to calculate the EMI of that loan. When you click on the calculate button, the data in this form will be sent to our calculate route. And we have already discussed the logic inside calculate route. Do let me know in the comments if you have any questions or any input. Now that we have our index.html, it is time for us to create the result.html file. One section where we are displaying the heading or the loan details or monthly payment EMI. In another section, we are just displaying the amortization chart right over here. And I have created a table to display the payment schedule. Now let's design our application. Here I have copied some of the things from Bootstrap and I have written some of the things from my side. You did it. Room 3 is behind you, and now step into room 4, testing and debugging. Let me execute the application. Now Python app.py. Click on the URL. Right, so this is my index page. Here we have a form to enter our loan detail, like the loan amount or the interest rate. So the first scenario is normal loan scenario. Let's say you took a loan of 5 lakh rupees and the annual rate of interest is 8.5 for, let's say, 5 years, and I'll give the start date as today's date, 15th of September. Now if I click on calculate, it should give me all the details. Calculate. So we have a graph here, right? And this is the payment schedule. My interest is 3,000, and from 10,000 I'm just paying 6,716 as the principal amount, and the interest is too high at this point. If you check the values below, let's take this. The interest is going to be low, but the payment is going to be high. So this is our first scenario. We also have the amortization chart. Here we have 5 lakh as the loan amount, and from 5 lakhs we are just reducing the total amount till 60 years. So this is the total loan, interest rate, and monthly EMI payment should be around 10,258.27 rupees. Alright, now let's do some negative testing. Let's see if this application is able to handle zero value or negative value. For this, I'm going to give loan amount as 0, and this is going to be 8%. Tenure is 12 months. I'll not give any date. Let's say calculate. So here is the error message. Amount and term must be positive. Rate cannot be negative. Okay. So let me say this is minus 1 lakh rupees. 8 and then 12, which is fine. Calculate. Again, we are getting the same error, which is good. Now let's take a scenario where the loan amount is extremely high. Okay, so 10 billions. Right. So this is my amount, and rate of interest is, let's say, 10% for 10 months. Calculate. So here is our graph, and this is our payment schedule. Let's take an example where the loan taken is very low. So here is the schedule, and this is our graph. So this is our application. Now I wanted to show you the backend tables and the data inside those tables. For that, I have a software called SQLite Studio. You can download this, which is free. Now here I have to add my database, right? To add a new database, I'll just click on database, add a database, select the database from loans. Okay. So this is our loans database. Inside this, I have two tables, loans and payments. Let me execute our first SQL statement just to see the data from table. Select star from loans, execute. So this is our table. Let me execute one more SQL statement. Select star from payments. Alright, so this is our payments table data. You did it. You have escaped the loan calculation maze and built a tool that can help anyone understand their loan payments. Next week, we are building a cryptocurrency portfolio tracker with live prices. Subscribe so you don't miss the adventure. Try adding extra payment feature to this calculator and share your code in the comments. I will feature the best solution in the next video. Like, subscribe, and check out my budget calculator video, link in description for your next coding escape. Thank you for watching. See you in the next one.